Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Semiconductor Devices and Integrated Circuits of semester 4. Today we are going to discuss is unit 3, the field effect transistor. The topics that we are going to cover today are junction field effect transistor construction and working, and its transfer characteristics, some of the parameters of junction field effect transistor, and how this junction field effect transistor works as an amplifier. These are the topics today we are going to cover. Let's start with the field effect transistor. What do you mean by field effect transistor? What its symbol? How it works? And what are the characteristics? Let's start with the field effect transistor. Field effect transistor, it means that comparing with the BJT and FET. What in the case of BJT? BJT we have, it is a bipolar junction transistor. Bipolar in the sense it having the conduction will take place in the two types of charges, that is, one is hole or electron. Electron and hole both will take part in the conduction. And whereas in field effect transistor it is unipolar device, in the sense it will be have the conduction will takes place only in the one type of material, one type of carriers, that is holes, either holes or electrons. And also the BJT is a current control device, and whereas the FET is a voltage control device. The figure here shows the physical appearance of a field transistor. Why we need a field effect transistor? It means there are two disadvantages that we observed in the BJT, that is bipolar junction transistor. One is it is having low input impedance, and also it is having a very high noise. These two made us to go for a new device. That is why now we are learning about field effect transistor. So let's start with the field effect transistor classification. How it is going to classify, and how it is going to be, what are the classifications of field effect transistor. Field effect transistors are classified as JFET and MOSFET or MOSFET. It is also called as IGFET. In JFET, that is junction field effect transistor, is again classified as a two. One is N channel JFET, another one is P channel JFET. Today we are going to discuss with this JFET only. In the next session we will discuss about MOSFET. The MOSFET is metal oxide semiconductor field effect transistor. It is also called as isolated gate field effect transistor. This is again classified as enhancement MOSFET, depletion MOSFET. Again, that enhancement MOSFET is classified as N channel MOSFET and P channel E MOSFET, both as an enhancement MOSFET. Again, the depletion MOSFET is classified as N channel D MOSFET, P channel D MOSFET. This is what the classification of FET. Next we come to the symbol. How the symbol of an FET? This is a symbol of only FET. This is not a symbol of a MOSFET. Don't confuse with that. This is the symbol of JFET, that is the first classification that we learned, JFET. It is one of the type N channel JFET. This is P channel JFET. In a JFET it is having three terminal, drain, gate and source. The gate current is flowing inward, and in the P channel the gate current is flowing outward. This is a major difference. In the structure we will make out some of the difference in N channel and P channel. Next we move on to advantages of FET. As I said, while learning, it's very good to compare the two that what we learned previously, that is a BJT and FET, it makes us to understand better. So, what are the advantages of FET? Very high input impedance, as I said, it will be having very high input impedance. We can also use BJT, we can make the low input impedance of a transistor, that is BJT high, by while designing properly we can make it, but as the complexity of design increases, this also leads to design complexity. So, we need to go for another device which is having high input impedance, that is where we are not going to use a bipolar junction transistor. This is having very high input impedance, approximately 109 to 1012 ohms, and source and drain are interchangeable. There is a source and drain which can be used as a source or drain, and it can be interchanged. The terminals can be interchanged, not exactly the source has to be used as source terminal, the drain has to be used as drain terminal. It is not mandatory here. The low voltage, low current operation is possible. That is when nowadays the low power circuits are more popular. So, this kind of device is used in a low power, low voltage circuits. Less noisy, as I said, why it is less noisy means compared to the BJT, it is having in BJT there are 2 junctions, but this one FET, the junction is less, only one junction will be there. So, due to the less junction, the noise will be less. No minority carrier storage, turn off is faster. Since there is no minority carriers, we can easily turn off this device, and very small in size, occupies very small space in ICs. This is one of the advantage. Next we move on to comparison of BJT and the FET. How the FET is different from BJT. BJT is also having 3 terminals. How we are going to make a conduction here? The current is controlled. The collector current is going to control by base current, and collector current is going to flow through the emitter. This is how the BJT works. Hence, BJT is called as current controlled device. Whereas in FET, what happens? The gate current, the gate voltage, gate to source voltage VGS is going to control the drain current, where the drain current is flows from drain to source. Using where the gate to source voltage will going to control the drain current. That is why we are called the FET as a voltage controlled device. Next we move on to the JFET construction. As we know, JFET is having 2 types, one is N channel, another one is P channel. Why it is N channel? In the construction we can observe 2 things. There is a N bar in the middle. It is having N bar and it is having P or P type material at the sides, forming PN junction at the sides and having N bar in the center. That is why it is called as N channel JFET. The gate is internally shorted, the drain, and this is the drain terminal, this is the source terminal. This is how the structure of N channel JFET. When it comes to P channel JFET, we observe the P channel, the P bar, P type of material as a bar in the center and N type material at the sides, forming 2 BN junction at the sides. And again the gate is internally shorted. This is the drain terminal, this is the source terminal. This is a difference between P channel and N channel JFET. Next we move on to N channel JFET operation. Now the N channel JFET operation has how the circuit connection will be in the N channel JFET operation is like this. How we are going to bias means the gate to source voltage is always reverse biased and the current is made to flow from the drain to source. In the sense, electron should flow from source to drain. And the first condition in the JFET operation is when we are not going to apply the gate to source voltage, what happens? There will be no gate to source voltage. When we apply the drain voltage, that is where drain to source voltage, the depletion layer is formed in a 2 type of PN junction at the sides. This is the depletion formation of depletion layer. This will make the channel width will going to decrease. Since the channel width is decreased, the current flow is also decreased. So, the resistance will be increased, the current flow will be decreased. So, what we can study from this, as we increase the VDS, the depletion layer will increase, so that the channel width will be decreased and hence the resistance will increase, the current will decrease. This is what we study from the first condition. Next we move on to next one, second condition. What happens when we apply gate to source voltage? Let us see. When we apply the gate to source voltage, the depletion layer again is formed, will be go on increasing. As we apply gate to source voltage, the depletion layer go on increasing, the channel width will be decreasing, hence the current will be also decreased. So, the inference is, as we increase the reverse voltage, there will be a reduction in the drain current. Drain current will go on reducing and the channel width will also decreases. This is what we study from the operation of a JFET. Next we move on to output characteristics of JFET. The output characteristics of JFET has it's a curve between drain current and the drain to source voltage with keeping the VGS constant. This is how it looks. The output, this is the output characteristics, we also called as drain characteristics, where the ID, the drain current is drain current versus drain source voltage is plotted keeping gate to source voltage constant like this. Here we can observe for different we will get the curve for a family of curve, we will get for a different value of gate to source voltage. And here there is one more voltage called Vp, that is pinch off voltage. This is the voltage at which drain current is maximum. After this point it is reaching a constant value. This voltage, this drain to source voltage is called as pinch off voltage. It is a drain to source voltage at which drain current is a maximal value, after which it reaches a constant value. That voltage is called as a pinch off voltage. And the circuit diagram for output characteristics will be like this, where we need a VGS. So, the voltmeter is connected here, the VDS is noted down here, ID current which will be varied with the rheostat here also, which can be varied, the ID current will be varied with the rheostat and VDS will be noted down here. And this is a reverse biased voltage that is giving for a N channel JFET. Next, some of the important terms that we need to know about JFET are the shorted gate drain current, that is IDSS, we commonly called as IDSS, shorted gate drain current. It is a current source short circuited to the gate and drain voltage equal to pinch off voltage. It is sometimes also called as zero bias current, that is what IDSS. From the curve of the drain characteristic we can easily observe, this is the IDS where VGS is 0, VGS is equal to 0 and this IDSS is also equal to when VP is equal to this point ID, that point is called as IDSS, which can be observed clearly from the curve, where when the VGS is equal to 0, the current will be reaching a maximum value at pinch off voltage. When VGS is equal to 0, that value of current is called IDSS, that is why it is called gate shorted current when VGS is equal to 0. And above this, above VP, below VDS max, the region between this VP greater than VDS is lesser than VP is equal to is called as a active region, and in between this region the JFET works as a constant current device, and this is a where we can say that JFET is working as properly, that is what is called as active region. And above the VDS max we can say that JFET is in a breakdown condition. So, this is what we can observe from the drain characteristics of JFET. Let us have a short break. Welcome back after a short break. In the previous session that we are discussing about important terms of JFET, that is what shorted gate drain current, that IDSS. Now we move on to pinch off voltage. What do you mean by pinch off voltage? It is a minimum drain source voltage after which the ID, the drain current is constant. That is called as a pinch off voltage. And from the figure we can observe the pinch off voltage for a different family of curves. This is the VP is called as pinch off voltage where it touches ID, the maximum value of ID. After this the ID value is constant. Next, one more important term is gate source cutoff voltage. It is the gate source voltage where the channel is completely cut off and the drain current becomes 0. That is when the JFET is in off mode. The voltage VGS is off. When we are going to decrease the reverse voltage, the reverse voltage is completely decreased, a point at which the JFET turned off, that voltage is called as VGS off. As the reverse voltage increased, from the figure we can clearly observe what I said. VGS, as we decrease the VGS, at this point the ID will completely become 0. This voltage is called as voltage of gate to source voltage of cutoff gate to source voltage. This point is called as cutoff gate to source voltage at which the drain current is 0. And also one more thing we need to observe, it's at some reverse gate source voltage, the depletion layer extends completely across the channel and the depletion layer almost touches each other. There will be no channel at all. At that point we call JFET is in cutoff mode and the drain current reduces completely to 0. Okay, then this VGS is equal to off means if the value of VGS is equal to 6 volts, the VP will be here in this first quadrant, it will be positive 6. This is a main difference about VP and VGS. VGS cutoff voltage is ID is equal to 0 and whereas VP is when ID is in a maximum value and VGS is equal to 0. Next, some of the salient features, some of the important points that we need to remember about JFET are, it is a 3-terminal voltage controlled semiconductor device, okay, and the input voltage controls the drain current, that is also we learned, and it is always operated with the gate to source reverse voltage. This is an important point. Why we are giving reverse voltage means we need to have a high input impedance, and also the gate current is always 0. For proper operation of JFET, the IG is equal to 0 always. Since there is no gate current, ID is always equal to IS. And JFET must be operated between VGS and VGS off, that is what it is always operated in VGS, that is gate to source voltage and gate to source cutoff, between the cutoff and between the gate to source voltage. For this range of gate to source voltage, ID will vary from a maximum of IDSS to a minimum of almost 0. ID will reach a maximum value also in this range and it also reaches 0. Because the two gates are at the same potential, since we observe from the structure there are two gates, that is the PN junction will be PN junction will be there at the sides. So as we change the voltage, the depletion layer will also equally the depletion layer will be changed. The JFET is not subjected to any thermal runaway when the temperature of the device increased. The drain current ID is controlled by changing the channel width. Yes, we are going to change the channel width to change the drain current. JFET has no gate current and hence we can say there is no beta rating for the JFET. These are the important points that we need to remember about JFET. Next we move on to drain current expression. This is called as a transfer characteristics, that is we know it is plotted across ID and VDS, constant value of VGS. This is called as a transfer characteristics or transconductor characteristics. Okay, we have plotted both simultaneously so that it will be easier. As I said, IGS is equal to IP and IGS is always equal to IP having opposite signs. This is what we get from this curve. And from this also we can have the ID current expression as IDSS into 1 minus VGS divided by VGS of whole square, where ID is equal to drain current at given VGS, IDS is the shorted gate drain current and VGS is the gate source voltage, VGS is equal to gate source cutoff voltage. This is what the expression for ID, drain current. Next, some of the parameters, important parameters of junction field effect transistor are AC drain resistance, that is RD. What do you mean by AC drain resistance? It is the ratio of change in drain source voltage, that is VDS, to the change in a drain current, that is ID, at constant gate to source voltage, that is where we mention it as delta VDS divided by delta ID at constant VGS. If we vary the small VDS, there will be a small variation, large variation in ID, which will give the AC drain current at constant VGS. If we vary drain to source voltage of small value, the drain current will be vary at large value. This is what the drain resistance. Next, we move on to transconductance. Transconductance is the ratio of ID and VGS, gate to source voltage, at constant VDS. It is the ratio of drain current to gate to source voltage. Next, amplification factor nu. It is the ratio of drain to source voltage to drain to gate to source voltage at constant drain current. This is the amplification factor nu for a JFET. Next, how does the JFET works as an amplifier? Let us see how it works. From the picture we can observe that this will looks like a common emitter BJT, and it is also works similar to that. When the reverse voltage is increased, that is during the positive cycle, the reverse voltage is less. So, during the positive cycles, what happened due to the reverse voltage is less means the current in the JFET will increase, because the channel will be of more and the depletion layer is decreased. So, in positive cycle, drain current will be more and also the channel width also more, and during the negative cycle the reverse voltage will be increased, so that the depletion layer increases, the channel width decreases, and the ID or drain current will decreases in the negative cycle. This is what we can explain from the application. So, what we inform is, for a small change in the voltage, we will get a large drain current. So, this is a good for amplification purpose. This is how the JFET works as an amplifier. Next, some of the application of JFET are as a buffer amplifier it will going to use, and as a phase shift oscillator as RF amplifiers. Next, summary: JFET is a unipolar device and it is a voltage controlled device, and the drain characteristics what we studied, and also the transfer characteristics, some of the important terms that are AC drain resistance, amplification factor, and the transconductance, everything we are come across, and also the lastly that how we are going to use JFET as an amplifier, which is works as a common emitter BJT transistor. Questions of this session: what is pinch off voltage? Why is the input impedance of JFET more than that of the transistor? What is the importance of JFET? Why is JFET called unipolar transistor? For further readings, you can refer www.talkingelectronics.com, and you can read the book Electronic Devices and Circuit by G.K. Mittal. This ends up the session. Thank you.
Right.